Hello, everyone. Welcome and thank you for joining. Today, we're going to talk about Supersonic Subatomic Java with Quarkus, the Kubernetes Cloud Native runtime, and what it is all about. My name is Anna Maria Taljanec. I'm a senior consultant at IBM. As part of IBM's service line, I'm working mainly on application modernization projects and enterprise cloud migrations for the telecommunication, banking, government, and other industries. But also I'm participating in a lot of initiatives within IBM and outside of IBM where I'm exploring a lot cloud native runtimes. So what is Quarkus? Quarkus is a stack for writing enterprise Java applications, optimized and adopted for the cloud environment. And when we say cloud environment, we mean container orchestration platforms like Kubernetes or OpenShift. And we are driving towards microservice architecture, adopting the 12-factor app and this isolated world of containers. But what additionally Quarkus brings is it tries to move enterprise Java into the serverless world. So like we're talking about Amazon Lambdas and functions and so on. So also it enables like two paradigms, like using reactive or imperative paradigms. So we have full support for event-driven architectures and reactive streams and reactive messaging and things like that. It's not that Quarkus is restricted to such type of application environments. You can write monolithic applications, traditional enterprise applications. It's just that the focus and roadmap of Quarkus is designed around these types of environments. So Quarkus is a container-first platform. Its main goal is around low memory footprint and low memory usage. But also it brings up fast startup time, boot up time, first time to serve, which is an ideal case for the Kubernetes environment, for the cloud environment at all. Because when you have cloud environments, you're restricted with resources. And if your application is using less memory and less CPU, that's a good thing because you can run more containers, mod pods with the same memory as you can with some other Java stack. Another thing is also the cloud migration from a monolithic traditional enterprise application to a microservice application. So like decoupling your application into smaller pieces. And also there's the serverless case where we want to have fast cold starts of our application, where we basically are paying based on the usage of the time that we use our function. So Quarkus is a good fit for such a case. And as we mentioned, the reactive and event-driven architecture. So Quarkus has a lot of support around reactive streams and reactive messaging, adopting things like Kafka Stream and so on. So if we look at the evolution of Java enterprise stack, we have here on the left side a traditional Java stack. So we're basically running on top of a virtual machine or a hardware machine, where we have traditional Java enterprise application servers that run on top of a Java virtual machine. And that Java virtual machine is actually optimized to enable features inside the application server, like usage of threads, dynamic proxies, and dynamic behavior overall, which gives a lot of weight to our whole setup. Also, on top of that, we often have libraries, so different application frameworks that also use these kind of dynamic features and add extra weight on top of all of that, which is traditionally a good thing because such libraries and application server APIs enable us to write fast, to speed up our development. It handles a lot of stuff for us that we usually would do for ourselves. And on top of that, we often have a multi-application setup where multiple applications are running inside that application server and sharing the same resources. So moving now more into this microservice world, we have more cloud native stacks where it's more lightweight. We have a Java virtual machine, often on top of which we build different libraries and frameworks that are more lightweight, so compared to the traditional stack. And we have a single app. So we have like a closed world principle with an environment that's basically immutable. It's not changing. And Quarkus, on that hand, takes advantage of such things. So basically, it says, okay, this is an environment that won't change. This is a closed world. We know everything about this application. So we can optimize it to be more performant and more optimized for the cloud environment underneath. So
sorry to interrupt you. Are you sharing your slide?
Yeah, you're not seeing it?
We are not seeing anything. So can you share your slide?
That's an issue. Can you see it now?
Yes, yes. Thank you.
Thank you. Yeah, so I was talking about this mainly. So Quarkus has these two types of runtime modes. So it has this native mode and non-native mode. So when we talk about a non-native mode, we have a Java classic jar that runs on top of a Java virtual machine, like OpenJ9 or HotSpot or OpenJDK or whatsoever. But even in this non-native mode, Quarkus does a lot of optimization on top of our application to make it more performant and more optimized for the cloud environment. The other thing is, if we use the so-called native mode, we are utilizing GraalVM's native image compilation to get executable image, so a native image. So basically what it does, this native image within it also has a JVM, but it's like a subset of the original JVM with just features that our application needs. It's also optimized in the means that it does a lot of dead code elimination, and it throws out basically all the things that we don't need, which is, of course, a good thing. And that way, we are getting at the end an executable that has a really low memory footprint and enables us to have a fast startup time. So here is a slide about some performance diagrams around native Quarkus in native mode, in non-native mode, and a traditional Java stack. So basically, what we can see here, we can get a boost in our performance. So like have an application that's 10 times smaller than a traditional Java enterprise application, and on the other hand, get a performance in like first response time that's like 100 times faster. Of course, this is a sample app that you can actually look up. It's on the Quarkus pages, and you can also test it out yourself. But it's dependent on which features you're using inside your application, so you can get different results. So what is GraalVM? GraalVM is a Java development kit that enables you to run really efficient Java code. So it's basically enables you to run Java or other JVM compliant languages like Scala or Kotlin, but also dynamic languages like JavaScript, R, and C, C++. And it has a lot of aspects, like it has polyglot support, it has this native image compilation support, which Quarkus uses. So basically, these red boxes are the main thing for Quarkus. So this ahead-of-time compilation of native images enables to do aggressive dead code elimination, and it analyzes basically your application So for example, if we took a library like Hibernate has a lot of support for different databases like Oracle or DB2 or other. But inside your application, for example, you're just using H2. So you really don't need all of these other supports. So what it does, actually, it throws out everything that you really don't need. But it has a lot of constraints, like for GraalVM, dynamic language features are a problem. Reflections are a problem. So what Quarkus does, it basically prepares your application for GraalVM native image compilation. So it gives all the instructions to the GraalVM compiler what are actually the reflections that you're using, registering it, what are the configurations that you're using, so it knows about them, so that during native image compilation, it can optimize your application efficiently. So one of the main features around Quarkus is this developer joy. So it tries to do a lot of tooling that gives you extra boost as a developer. So like it has this thing called dev mode, which I will show you later on. But it also has, like, for example, there's a lot of effort in writing nice error handlings, like getting nice exceptions that are descriptive enough to point you into the right direction. It has a lot of tooling support, like it has a Maven plugin, or it supports also Gradle. It has plugins for all the popular IDEs, so like for Eclipse, VS Code, or IntelliJ. And a lot of effort is thrown within the community to help the developers get an excellent experience. It's built on top of well-known common libraries. So as you can see here, here are some of them. It defines these called extensions. So what it is, it's basically a pre-optimized version of those libraries that you see here. Like pre-optimized in a way that everything is prepared for those libraries to be plugged into the native image compiler and into the Quarkus build processor. So basically defining if it also has a thing around configuration. So if it uses this zero config, which basically tells you that it tries to put all of the configuration into one place, making it easier for you as a developer. So looking at these extensions, it basically will define configuration items for each of them that are specific for each extension, for each library. For example, for data source, it will define all the needed parameters so that you can successfully make a database connection, but all in the same place together with other configurations. Quarkus implements the micro profile specification, so it's a reference implementation, and it currently supports the 3.3 micro profile standard. So on the left side, we can see all the common APIs that are inside of micro profile, and on the right side, we can see these umbrella projects, so which Quarkus also implements, like long-running actions and GraphQL. Reactive streams, reactive messaging, and so on. So this is like this is showing you how the Quarkus build process actually looks like. So basically, Quarkus takes your application and tries to move as much as things from the runtime to the build time. So during your Maven or Gradle build, it basically there's a phase within the Maven build lifecycle that Quarkus pulls in and basically gets a view of your whole application. It analyzes your classes. It does annotation lookup. It basically tries to do everything during build time to optimize your application. So like dead code elimination, throw out things that aren't really necessary, but not only at your application level, but also at the library level. So, for example, as I mentioned earlier, the Hibernate case. So after that, it basically, as we mentioned, has these two modes of working. So like using the native mode and the non-native mode, where we can choose to use JVM. So basically mode using some JVM implementation, and on the other thing, on the other side, have a native image compilation. So now we're going to do a little demo around this. So since we don't having a lot of time, I actually prepared some sample applications, more focusing on the microprofile side of Quarkus. So the first thing I want to show you is so the extension part. So actually, when you start developing a Quarkus application, a good thing is maybe to start from the code Quarkus IO page. So here you can bootstrap a simple creation of an application with some extensions that you want to use. For example, like REST client, REST service, data, so basically Hibernate ORM, different JDBC driver, like classic JDBC driver or reactive JDBC drivers. Also, it has a lot of support regarding messaging, microprofile, reactive. So Quarkus is reactive within its core. It uses Vertex and Netty. But it doesn't enforce anything of that to you. You can use whatever paradigm is easier for you. It has a really nice thing related to compatibility. So a lot of Java programmers are used to use Spring. So it has this whole compatibility layer for Spring. So you can basically take your Spring application and port it into Quarkus, and it will run, basically. So it like speeds up the transition for you to get acquainted with Quarkus, and then later on maybe use the more advanced stuff. So we would first power up this dev mode. So to show you how a development in Quarkus would look like. So the idea is to basically to code something and test it right away. So like code, save, test. And if it fails, you can immediately see it, change it, and it can run again. So for example, we are now using this account service application. It has a simple REST controller. Yeah, and I used Panache here. So again, you could use maybe Spring Data if you're more used to it, but Panache is a neat thing to basically define entities and data access objects around it. And here, for example, we are retrieving a list of accounts. We defined a database here. So like I'm using this prod profile where I have a data source, which is described with this URL. So based on the URL, Quarkus will understand that sorry, dev mode. So Quarkus will understand that this is a H2 database that I'm using. And I gave him some configurations like how the data source should look like, that I want the create and drop feature of Hibernate to be enabled, and to import some data. So looking at the data, we have some simple account, which has a couple of properties, which we defined here, of course. So so looking here, Quarkus is up. We can go and test our simple application by Swagger UI, maybe. Whoops. Okay. So, ooh, nothing. Yeah. Okay, so I didn't put up Swagger, obviously, but I can try this. Ciao. Cool. Yeah, and let's change this to something else, like hello too. Whoa, no pointer. Hello too. Okay, didn't save it. Okay, so for example, let's do something like defining micro profile configuration here. So let's inject config. Okay. Save. Okay, and it's going to be a string called greeting. Cool. And I will put it right here. Okay. Whoops. Seems nice now. Let's try it now. I get an exception. Yeah, there's no greeting defined. Okay, let's try it this way. Let's have a default value saying default. Did I save? I think I did. Okay. Yeah, it's working. So another thing that we can do here is like define it here at the application properties where our configurations are there and call it, I don't know, hello. Okay. And it's visible. Yeah. Okay. So looking at this other sample I did, we defined here, for example, a REST client. So basically, we took this REST endpoint here, this resource that I defined to list all the accounts that I defined in another application, a REST client. So it's based on, again, on microprofile. And throughout this simple controller, this resource, I exposed it, for example, here for this endpoint. So, okay, let's try it out. It's accounts and hello. Localhost. Yeah, I think I have Swag. Okay, I don't have. Oh, I didn't put it up. That's interesting also. Okay. Okay, I put the first application actually is using the debug port, so it's saying here that just already used. Okay, so now going here again. Oh yeah, it's loaded up. So here I can see this hello account. So I can try it out. And I'm getting all of the accounts from the other application. So if we look at the application properties, we can see here that I defined this REST client using using this configuration. A nice thing in the Eclipse Quarkus plugin is that it gives you this auto-completion regarding configurations. So it kind of speeds up the process of configuring here. So this dev mode is really neat because you can also use it now in basically in a remote way, like connecting to an OpenShift environment, a Kubernetes environment, where you can do this dev mode on a running container, which is also nice. And for example, here I also did, I used a Minikube that I have locally set up. and I connected to the IBM Cloud Registry to push my container that is defined to this microprofile demo. So you can see the configuration here, how it is defined. And a good thing here is that if you just enable this Kubernetes extension, so there's a lot of ways to add an extension, but it's basically just adding something in your POM XML. And basically, just by adding this Minikube or Kubernetes or OpenShift dependency here, this extension, you have everything that you need to start deploying into a Kubernetes runtime. So what Quarkus does, actually, it generates all the stuff regarding like the Kubernetes YAML file or Minikube YAML file, so services, deployments. It basically wraps everything up for you so that you can have a neat experience around this. Also, I used here the Docker builder, but there's other options that you can use. For example, one of my actually favorites is Jib. So it enables you to build a Docker image without actually having a Docker daemon locally installed, which is kind of nice. Yeah, we are, I think, out of time. So I will just return to my presentation. So Quarkus is an open source project powered by Red Hat, and it's actually has a really friendly community, great people working on it. And here are some links regarding the main page, their GitHub repo, and Zulip chat, also Google mailing list, where you can find interesting things around that and request for features and report bugs or issues, and start maybe contributing to it. So questions?
If you go to chat, you can see all the questions.
Just, oh, yeah, now I can. Well, regarding microprofile versus Spring. So, for example, here at the region I work with, we are having more of Spring developers. So basically, it's more in the Spring favor. But after what I actually experience when people start using Quarkus, they actually try to migrate to other stuff, mostly the reactive stuff. I don't know why, but it's like everyone needs reactive things today. Quarkus with Groovy, I'm not aware of that, but there are a lot of people using Scala. Native image, yeah. Regarding native image compilation, yeah, it's actually heavy on your machine. So when you do this native image compilation, it takes a lot of time, and it's actually taking a lot of resources. So if you have any questions, please reach out. I will be more than happy to discuss this and answer whatever is on your mind. Thank you.